go to the series, power series. Power series is like this concept. Now it is exactly the same concept with our real valued functions. Okay, exactly the same value concept means in the real value, if I'm having I've given you Taylor series formula, right? The same Taylor series formula, instead of x, just substitute z. That's all. Okay, that will give you a complex function series. Oh, got it, right? Let me take this example. Okay, 1 by x, 1 by 1 minus x is equal to 1 minus x the whole power minus 1. The series of this term is nothing but 1 plus x square plus x cube, like that. Which means in the Taylor series I told you, right? In the Taylor series, like for calculus, I have given in the Taylor series. If I'm evaluating a function is there, okay, a function is there. This is e power so let me take an exponential function. Okay, this is my exponential function. Okay, in this exponential function e power x, I want to replace this function with a bunch of polynomials. That is the power, that is the series. Okay, because polynomials means, what is the advantage of polynomial means, they are very easy to differentiate, very easy to integrate. Okay, instead of having a complex function, we can simply approximate the particular function. For example, in our problem, in our day-to-day engineering problem, I'm having some complex function in the system means, if I need some approximate solution means, directly instead of using e power x, I can use the polynomial. I can use this particular polynomial. Okay, so in calculus, if you attended my chapter, calculus lecture, I have taught you this Taylor series very elaborately. So I have picturized that what is Taylor series means, and I have taught you things very elaborately. The same concept here only. This is the formula for Taylor series. Okay, about a point x is equal to a, f of x is equal to f of a plus f dash of a divided by 1 factorial into x minus a plus f double dash of a by 2 factorial x minus a whole power 2 plus f double dash of a by 3 factorial x minus a the whole cube. Okay, this is the, actually you might have known this formula. This is like Taylor series from our calculus. Okay, therefore, what is the Taylor series of e power x? E power x means at x is equal to 0. E power x at x is equal to 0. For that, simply f of x is equal to e power x evaluate at 0, which is 1. F double dash of x is nothing but it's same e power x. If you evaluate at x is equal to 0, it is also 1. F double dash of x is also 1. Triple dash of x is also. So whatever the order you are going, the answer is always 1. Okay. So just substitute that value here in the formula, Taylor's formula. The answer is 1 plus x divided by 2 factorial plus x divided by 3 factorial. This is your Taylor's formula for epsilon naught exponential of x. Okay, for exponential of x, answer is f of a plus f dash of a by 1 factorial x. Because at evaluated x is equal to a, right? Got it, right? F double dash of a divided by 2 factorial x square plus f double dash of a divided by, here a is equal to 0, guys. Okay, here a is equal to 0, the value a is equal to 0. F triple dash of a at 3 factorial x cube, something like that. So f double dash, all the things are triple dash, everything is 1, the value is 1. Substitute that 1 plus x by 1 factorial plus x squared by 2 factorial plus like that exponential of x. This is your normal Taylor series in real valued function. Okay, so the formula for Taylor series is like summation of n tends to 0. Okay, since it is a series, okay, n tends to 0 to infinity, f of n the whole power a divided by n factorial plus x minus a the whole power n. This symbol means summation, guys. Okay, the symbol of this, I'll expand the symbol here. F of x is nothing but sigma n is equal to 0 to infinity, right? Then fn of a divided by n factorial x minus a the whole power n. This particular summation, this is called, they'll pronounce it as summation. Okay, summation means just sum it. The symbol summation means sum it. For n is equal to 0, substitute n equal to 0 here. Then f of 0 a divided by 0 factorial x minus a the whole power 0 plus, then substitute n is equal to 1. f of 1a divided by 1 factorial, okay, x minus a the whole power 1, okay, then f 2 of a divided by 2 factorial x minus a the whole power 2. You got it, right? Just have to sum it up to infinity. That is the the shortest form of representing this is nothing but summation of n equal to 0, fn the whole power n divided by n factorial x minus a the whole power n. You got it, right? Because 0 factorial is 1, x minus a the whole power 0 is also 1. It is nothing but simply f of a. They evaluated it f of a. Okay, 1 plus, the answer start with, this is also 1. So 1 plus f of a divided by 1 factorial x. You got it, right? That is the formula for Taylor series. You got it, right?